Hello and welcome to the Conscious Design Podcast, where sustainability meets innovation and business savvy. I'm your host, Ian Peterman, CEO and founder of the Peterman Design Firm, a hub for green tech and visionary ideas. Join me as we chat with Per Hassel. He's a founder and R&D manager of Podbike, where they've developed the next generation of e-assisted vehicles, merging the convenience and comfort of cars with the benefits of and excitement of cycling. Welcome to the show.
Thank you, Ian, for having me.
Well, I'm really excited to dive into this product. I know you're definitely on the technical side. We're going to jump into technical, but everybody loves to hear origin story. So let's go back in time. What got you to decide I want to tackle e-assisted transportation and really just get this off the ground?
Well, I've always been an avid cyclist. I love to ride my bikes. In the town where I was grown up, we had one of Europe's largest bicycle factories producing up to 600,000 bikes per year. And their scrapyard was very close to our house. So when I was a preschool child, I collected everything that looked usable. And my father had to throw it out of our garage about once a month, a big pile of parts I collected. But sometimes I managed to even make something of this. And I've been playing with bike parts ever since. And when I was 18, I also tried to make a record bike, trying to take a prize, a US prize of the first cyclist able to pedal faster than 55 miles per hour. And we tested it on a closed part of the highway, my friends and I, and sorry, we did not be successful there, but it was quite fun. And later I kind of went off the technical path and more into computers and software programming and electronics. So it wasn't until 2009 when I was hit by a car and I got really scared of riding a regular bicycle with two wheels. So I bought a Velomobile kit from the Netherlands. A Velomobile is a pedal cycle with a body, normally quite aerodynamic, so you can pedal quite fast. However, this kit from the Netherlands, that was not so good in hilly Norway. There's not so much hills in the Netherlands, so they probably did not see the need of speed going uphill. However, after a week, I put in a motor assist, 250 watt, which is the legal limit here in Europe. And then it became quite practical, and I used that contraption for about 7 years. It looked like the fuselage of a old-timer airplane. It was aluminium, looked like a cigar almost, without wings, of course. But my head was poking out on the top, so I was a bit exposed. Especially when there were hail, I really missed the windscreen. And in the summer, yeah, that was quite painful, especially going downhill in 30 miles an hour and hitting the hail in the face, not so nice. Yeah. And in the summer, when you have these downpours of summer rain, you don't know how deep these poodles are on the road. But in this Velomobile, there was a hole in the floor, so you can do the Flintstone reverse gear. You put your feet on the ground to go backwards, because there's the freewheel, so you can only pedal forward. So that's how you reverse. But when it's a lot of rain on the road, and you have poodles or dams, and you try to ride through them, if you are slightly lower than the water level with the underside of this vehicle, you siphon off the water. So you end up with water up to your chest and even further if you're having good speed. So that happens once. Luckily, it wasn't the summer, as I said, and the water wasn't so very cold. And I actually started laughing because I thought, this is the most stupid thing ever. I didn't get embarrassed, but one time I was going downhill in this Velomobile, and that was early in the spring, and there was ice on the road, which I were not aware of. So I was going maybe 20, 30 miles downhill, maybe slightly faster. I like to go a little bit fast. And then when I braked, I also brake with the rear wheel, which is not so smart. If there's a tendency to skid, and this is a so-called tadpole design with 2 wheels in the front and 1 in the rear, 3-wheeler.
Okay.
So when I go down and the rear wheels start to slide and I come like this and I tumble around 2 or 3 times. Luckily, I was the only vehicle in the street. And the first thing I was thinking of when I was lying on the side in the middle of the road, that was, this is super embarrassing. I hope nobody saw it. But in the next moment, I realized that I was totally unharmed in a quite high-speed accident. And if I had been riding my 2-wheeler, I would probably have had to go to the hospital. Now, I only needed to drill out some rivets and change some aluminium sheet on the Velomobile, because the Velomobile took all the blow, and you could see it on the body. But the good thing was that I was so protected by this, even with my head out. That was quite amazing. I do had a helmet on, a bike helmet. So there and then I realized that a Velomobile is a very good vehicle for efficient travel, because it's so light and uses little energy and doesn't need a lot of material to be made. So if we could make this a commercial thing, we should have a good market, because most of the Velomobiles today, they are made for maximum speed and don't benefit so much from electrical assist, because the electrical assist have a speed limit of, in Europe, it's 25 kilometers per hour, or about 15.5 miles. And in the US, you have different classes, but the low power class, which is the vehicle we make, it's 20 miles per hour speed limit for the assist motor. You can, of course, pedal faster or have help of gravity or wind or something. But 30 miles per hour, I think, is a good max speed for these kind of vehicles going downhill, and 20 on level road with the assist. And with very little extra material, you can make a very good protection. Of course, it will not help you if someone's coming super high speed in a car, but most crashes are in cities and areas where you have low speed limit. And usually people manage to at least reduce the speed somewhat. So most car-bike collisions, they are around, let's say, 10 miles an hour or something like that. So if we can protect the person inside at that speed, it's very good, yeah? So my accident, when I was hit by this car in 2009, I almost broke my neck and I crushed my knee. So I know I have a steel implant. And that was like 8 miles an hour. Very little speed. But of course, you decelerate in a very limited space when you use your body as crash zone. So it's not recommended.
Yes. Don't be a crash test dummy.
Yeah.
So now, when did you start developing, right? I know you had the unit, you added an electric motor, augmented, used that for a while. You knew the idea was good. When did you start really working on the version people can see on your website right now? When did you really start that and go, it's company time, let's go build this?
Okay. Well, this crash downhill, that was around 2010. And at that time, I also started to take a master's study in sustainable energy at the local university in Stavanger. And I asked my professor if I could write about a very energy efficient vehicle of this kind. And I got a green light on that. So that was the technical basis. That was a master thesis I wrote during that study. And that was finished in 2014. I also have to mention that I work as a product developer. And at the time I crashed with this car, I was working in the oil and gas industry, designing electronic instruments for use inside oil wells at elevated temperatures and quite high pressure, and also subsea instruments that's permanently located at the seafloor. And later I worked with charging infrastructure or charge safety equipment for electric cars for a major automotive brand. And during this period, I was riding this three-wheel Dutch 𝗏𝗏𝗯𝗏, and I collected the list of issues to fix. So one issue was the missing windscreen. The second one was the hole in the floor. I wanted to close that. A third one was that three-wheel is one too few. You really need the four-wheeler to have something that is stable and is not too big. You can make a three-wheeler stable, but then you need to make it larger than what a four-wheeler need to be. So the fourth wheel is quite essential when you're looking at space at the same time. And vehicles are always a compromise. So I had a list. I think it was 37 points on that list. And I put them into this master thesis where I broke it down into various topics. And I wrote quite a good manual, I would say, on how to make a 𝗏𝗏𝗏𝗏 like our product. And that thesis was finished 2014. And the year after, we had this oil crisis. And living in an area of Norway where oil and gas production is the main income or the main business, there were suddenly a lot of engineers available, and my wife, who's economic education, a master in business administration or similar, she had been given a economic benefit if she resigned voluntarily from the oil and gas company she was working in. And at the same time, we also get some funding from the state to start new business because there was a lot of unemployment around 2014, 2015 in the area. So we saw the opportunity, started in 2015. Officially, the company, Podbike, was registered in January 2016. But the technical specification was more or less what was in the master thesis. And then with the money, startup money, we hired a Norwegian guy who was working in Berkeley at that time with car design. His name is Per Hassel Sørensen, and he ran a company in Berkeley. And later he moved his company to Norway and merged it with an existing company there. And they even had got the main office in our neighbor city, so it was very short distance to meetings, etc. So we hired his company while he was in Berkeley, and he had been a chief designer at Peugeot and also at BMW and Rover and Cadillac and a few other companies, including I think it was an Italian company who made red sports car, but he weren't allowed to tell which company that was. But he and his team, they were brilliant, and they made the first exterior design, because exterior design is super important, especially when you're launching a product most people do not know exists. And we wanted to go one step further from the standard 𝗏𝗏𝗏𝗏. These are normally very, very low, like 70, 80 centimeters tall, and that would be around 3 feet. I'm not so used to the US units, but we made a taller vehicle. It's 125 centimeters tall, approximately, and that was to be compatible with existing cars. Like, okay, a Lamborghini Countach is like 110, Ford GT 40. That was 40 inches, I think. So it's 104 centimeters, very, very low. Ours is 125, so it's slightly taller than a fancy sports car. But it gives you the idea that it's actually taller than most 𝗏𝗏𝗏𝗏s because they are so much lower than even a sports car. And we also wanted to have as much creature comfort as possible. Normally on a 𝗏𝗏𝗏𝗏, you put on some cycling shoes, you put on short trousers, t-shirt, and you pedal so you really sweat. So it's a very good exercise. And you go fast. Actually, the world record is like 90 miles an hour.
Recumbent style, right?
Yeah. And that's only a two-wheeler. And then they call it Streamliner. But it is available. But the niche version has only two wheels. And those high-speed versions, they don't even have a windscreen. They use cameras to have minimum air drag. They're quite extreme. Every year at Battle Hill in Nevada, there's a world record tournament where they really try to break the past world record in this special niche of competition. Anyway, that was a distraction. But we wanted it to be spacious inside. We wanted to have room for a child in addition to an adult. We also wanted it to have no chain. It should be chainless to minimize maintenance, because high quality bikes really need a lot of maintenance to keep them at the top performing vehicle. So removing the chain, the cassette and the derailleur, all that stuff is gone. We have a pedal by wire system or a series hybrid where you pedal on a generator and the energy is transferred via cables to two motors in the rear, one on each rear wheel.
Okay. So you don't directly pedal like you would on a bike then, correct?
No, you can see this as a kind of bike simulator where the energy you put in the pedals is kind of amplified by the battery and goes out on the rear wheels. But you also have a feedback system so that when you go uphill, you notice that it becomes heavier to pedal. But you can also adjust the assist system so the amount of heaviness is kind of limited. You notice there's some extra resistance, but much less than what is put on to bring you up a steep hill. That you can adjust, okay? And you can also adjust the automatic gearing, because it will. Some people like to pedal fast and some like to pedal slow, and it's very easy to adjust this. There's a small joystick on each end of the handlebar where you tune the cadence or the pedal speed relative to the wheels, and where you also tune the assist.
All right, so that makes it very easy. This is much easier.
Yes. It's and when you pedal backwards, you start to slow down, and when it stops, it starts to go backwards, because there's no mechanical connection. So we try to implement software and control systems that makes things as easy to use as possible. At least in our mind, we think it's as easy to use as possible. Maybe we could make it even simpler, but we haven't found any better way to do this yet. And we've been testing a lot. We had finished the first mule that was actually a two-wheeler with one motor in the front wheel and one motor in the rear wheel and the pedal generator in the center, just to test the concept. And that was ready around 2016. And in 2017, we had a chassis ready and went to a show in Germany and showed it there. And 2018, we had the first body ready, or we had the first body made. It was not ready. It looked ready, but it wasn't ready, okay? That's why you make prototypes. That is to go the way from concept idea to making something that hopefully works. And then you find out that, okay, this works, but okay, 10% works as expected and 90% does not work at all, or at least not as expected, or much worse than it should be. So then you have iterations. And the good thing is that our bike is a kind of software-defined vehicle. So we update the vehicle by changing the software, and we can now do that over or via a mobile phone. We have developed our own app that is used as an interface, being the dashboard with the information about speed, battery status, etc. And it also have an internet connection to our cloud software where we have new firmware releases put up. And the app tells which vehicle you have and which software versions you have on the motor controllers, on the body controller, on the lights, etc. And since we developed everything ourselves, we have full control of all the software except the battery. That's the only thing we have bought externally: battery and charger. So we have 10.
Batteries are difficult, so that's.
It's not so difficult. I actually that was the first electronic board I made for this project. That was a battery management system, or BMS.
Oh, really? Okay.
But
what made you switch over to buying it?
Because when you make a battery, you need battery cells. And when you are a small company, at that time, we were quite small. Big companies like Panasonic or Samsung or Sony or whoever you want to buy those cells from, when you're a small company, they don't want to risk a little bit profit in case one of our batteries catch fire and burn down a house or something. And it says in the information in the news that this battery was made by Samsung or Sony or whatever. They really don't want to take the risk with small battery manufacturers to sell them their cells, because it is too risky for them to lose reputation if something goes wrong. So we couldn't get cells. We get 𝗡cie𝗁𝗃 cells, and I really wanted to use those, and suddenly the company was bankrupt. So that was what I designed this BMS for. That was 𝗡cie𝗁𝗃, because the 𝗡cie𝗁𝗃 cells, they have a huge benefit on e-bikes, especially here in Norway. They can be charged at freezing temperature. Most lithium-ion cells cannot be charged until they are a few degrees above freezing.
Yeah, and your winters get cold.
Yes, we get quite cold winters. And we have customers who want to our bike. We haven't delivered yet, but we have customers, I think it was Iceland or Greenland, and they also get quite cold in the winter. And we sell our bike as a year-round bike. However, we put the limit to -20, because when you design a system, you need to design it for a temperature operating range. So we have -20 degrees centigrade, not Fahrenheit, to up to plus 40 degrees centigrade. Okay, so we have 60 degrees centigrade operational range, and outside that range, we cannot guarantee the vehicle works. So a car, for instance, they typically design them for parking at -40 and operating at -30 or 35, I think. It probably depends what you need. And then you have the other issues. If it gets very warm or you have extreme UV exposure, you have new challenges. Like if you have a cabriolet in Florida, I guess you will have replace the soft top more often.
Oh yeah, the dashes. All those softer plastics, they'll just crack it. UV kills it.
Yeah, and that's another thing. When you also go from my single kit-built 𝗏𝗏𝗏, which is kind of I am the producer of, so I make a single vehicle, and then you go to prototypes where we made the biggest series we made was 12 identical ones for a test series we ran for 2 years, and then you want to go into mass production. And I think there is one guy in Texas, I think his name is Musk or something. He makes things, and he's right that making a prototype or constructing something, it's not so hard. But mass produce, or making many and having it approved by authorities, that is huge obstacle, to say the least. It's extremely...
That's where it gets expensive.
Yeah, we're still working on having our headlights approved in Germany. In Germany, bicycle lights have almost as heavy testing requirement and homologation requirements and type approval needs as car lights. For cars, it goes 10 times faster.
Wow. I would never have guessed that. That seems very, very high hurdle to hit.
It's a huge hurdle, and it's so extremely expensive. If you buy a German bike, make sure you get it with German lights. Then you get good lights. But of course, they are 3 times the price because somehow they need to get back the money they need to put into test laboratories, and they get all these stamps on the important papers, and paying all those guys sitting in the offices around in Germany. Okay, I shouldn't be talking too much about this because we still lack the last stamp on our headlight. We are selling the bike in Germany now, but without high beam. We're still working to get the high beam work approved.
So you're able to separate that though. So you're able to sell the low beam because that's been approved.
Yep. In Germany, there's no requirement for a high beam, and actually, most people don't have bike lights with high beam. So we just had a test in Germany in a German newspaper in outside Munich, and there was questions: what do you use the high beam for? So when you need to explain why you need that, what you use the high beam for, then you understand they are not used to it. We haven't had a lot of issues because we still lack it. And those bikes we have delivered, we will replace the headlights with new headlights that has the high beam. We need to deliver, and we have a lot of pre-orders. We have around 5,000 pre-orders, and many in Germany. We have started to deliver bikes in Germany even without high beam. But we have a low beam that has all the necessary stamps on it, so that's good. But very costly.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
So your design, it looks to me like it's small enough that it can still fit within. Does it technically get to go on bike lanes because it's pedaling, or is this? Do you have to be in the vehicle lane? Where can you use this?
Yeah, it's 84 centimeters wide, so it's not wider than a regular bike trailer with room for 2 kids. So as long as you can ride in the cycle path or cycle lane with the bike trailer, if there's space for that, then you can also ride our vehicle, which is named 𝗚cie𝗁𝗯𝗶, by the way, which is the Norwegian name equal to free man. So
Got it.
A person who's free, yeah. And we have made 𝗚cie𝗁𝗯𝗶 so that it is a legal e-bike within Europe or EU and the satellite states, which Norway is one of. And it has assist up to 25 kilometers per hour or 15.5 miles. And faster than that, you need to pedal. But since our bike is heavy, it's 100 kilo empty, it has a high rolling resistance due to the higher mass. And even though it's streamlined, aerodynamic, it became heavier than planned. The target was to reach, have a weight around 60 kilo, but then we found out we need a fan. because you want to keep fog away. And even though you have some distance to the windscreen, without the fan, when you have bad conditions, a lot of moisture in the air, there will be condensation. So the fan makes a very nice zone that is fresh air close to the windshield. We blow into the windshield, and the nice curved surface is then held at a low moisture content air film towards that windshield. And we also found out that we need to add a carpet because the noise level was quite high. And when you think of it, if you ever ridden a car which is from the 30s or 40s, a closed one, you can hear almost everything inside. Every bump, every explosion from the internal combustion engine, you hear a lot of noises. And our body, because they didn't have a lot of air or soundproofing, etc. They didn't add that at that time. Later they added. On a modern car, there's 50 kilo or maybe up to 150 kilo with materials added purely for sound or noise vibration harness, NVS.
Right. And yours is an enclosed vehicle as well, so you have all those same you have those same noises traveling inside.
Yeah. And we have plastic, which is quite thin. It's 2 or 3 millimeter. The canopy, we call it, it's made of polycarbonate, so it's very strong, and it has hard coating, so we can use the windscreen wiper on it. But the curvature helps to make sure that when you're sitting in the center, you hear a lot. It's very nice if you are resting and putting on a Bluetooth speaker inside. It's kind of surround, but it's not so nice when you were pedaling or riding over cobblestone or something. So we added about 1.5 kilo of soundproofing material.
Okay.
We sent one of our prototypes off to a car hi-fi company, and we asked them to do something about the sound, and they added 6 kilo. And when you have a human-powered vehicle, because in Europe, you have to be able to pedal it without battery assist, up to 10 kilometers per hour. That means it cannot be too heavy. So we have a limit there. And when you add 6 kilo of sound damping material, that was too much. So what we did was we actually went back to Germany, and then we spoke to the supplier of adhesive we use. We use quite advanced adhesives, and we have good cooperation with the supplier, which is a Swiss company, but they have an automotive laboratory for NVH issues or sound vibration harshness issues in Germany, where they can do what's called laser I don't remember how to pronounce it in English, but they measure interference of the parts, and they can actually visualize where noise sound is coming from. So we sent them a door, and they do a lot of shake, rattle, and roll, like really make it act as a drum skin or whatever. And then they find the resonant pattern much more accurate than what you can do with what we use normally, which is a FEA analysis of neat element analysis. And then they can find out where they need to add mass, what kind of damping properties that mass has to have, and the amount and the extension of it. So they sent back, and they even made a special recipe of damping material for us. Of course, if we did that exact, that was something they made in their laboratory. And if we needed to use that, we had to buy several tons, and we couldn't afford that. So we used something from the standard catalog, which was pretty close. So that's what we use. And the geometry and the location and everything, that was given to us by the supplier. So we had very good help there.
So it's rather than trying to coat everything, you're able to really focus on we need to take care of sound in these spots, and it'll do the most help.
Yes. Because as I said earlier, a vehicle is always a compromise, especially ours, because we have a kind of price roof. We cannot make it unlimitedly expensive. We cannot make a Rolls-Royce. Or maybe we will, but that's not the target. The target is to make as many as possible. And to do that and sell them, we need to have an acceptable price, okay? And then we need a mass which is acceptable to be pedaled by human power only to be illegal. And then it must fit in the bike line. So we started with 80 centimeters, and then we found out we need to grow a little bit. So we added 4 centimeters because we had some interference with the rear wheel suspension. And then it's a recumbent. And when you have a regular bicycle, when you're riding on cobblestone or very bumpy roads or over potholes, you stand on the pedals and you use your legs as damper, and you let the entire bike frame become what was called unsprung mass. Okay, so it has to float directly with the road, and your body stays more or less level while the vehicle goes up and down. When you have a recumbent, you cannot do that unless you have very good stomach muscles and lift yourself by, I don't know, the neck. So we have fully independent 4-wheel suspension, something that was unheard of in the 50s. It came in the 60s with the Jaguar E-Type and the, I think the Corvette also got it. But basically, fully independent suspension, that's something you only found on sports cars in the 60s, and now most cars has that. But on bikes, that means, especially on a 4-wheel bike, we need 4 dampers, 4 springs, 4 moving wheel carriers, and everything adds to the mass.
Right, yeah.
Yeah. And another thing is that even though you have suspension, we do have a motor in the rear wheel. And if we had a direct driven motor, you need very high torque to be able to propel it up a steep hill. I don't know if you've ever ridden an electric bike, but if you have, you will normally notice that the motor is usually not strong enough to ride up steep hills if it's not geared motor. And what we did was 2 things. We put the motor not into the hub, but very close to where it has the pivot in the rear suspension. So the motor is here. Let me see, here. So the motor is here, okay? And you have the hinge point here. So the motor moves up and down a bit, but not as much as the wheel, which is further out on the rear wheel arm. Just like a Vespa scooter, they have the entire engine as part of the unsprung mass. So the motor goes up and down, but most of the mass is very close to the pivot point of the rear suspension. So it's easier for the wheel to follow the undulation of the road. If you bring the engine mass, or in our case, a motor mass, into the wheel itself, you end up with a lot of unsprung mass. And if you go into a bump, it takes time to first accelerate the wheel with the motor upwards and then bring it down again. So then you get what's called floating. The rear wheel would start to float when you ride on uneven roads. And that makes steering quite uncontrollable. You have the rear wheels will float because they are not following the road. So you need to get the mass, unsprung mass down. And what we did was not to get the mass itself down, but the inertia of the movement down by moving most of the mass as close as possible to the axis of movement for the rear trailing arms.
Right. And these are all things you just don't think about, right? The first time you build a prototype, you put it all together and then you go, oh wait, this is a lot of mass out here. It's doing things we don't like.
So in my master thesis, I wrote that I should use hub motors with gearing and block them so I could use recuperation, use the motors to also brake. and go in the reverse. But the problem was that the existing motors, they were not very wear resistant. They wore out after 10,000 kilometers, 10,000 miles, and you had to really replace a lot of parts. So I went away from these hub motors and put in just a regular motor, but as close to the pivot point as possible. But the good thing with this is that we could get a motor at a reasonable cost that we got custom made for our purpose with our temperature sensor, winding, magnets, everything. It's a permanent magnet motor. And we used 3 of them. We also used a third one for the pedal generator, and they're all the same. So that means when we purchase part for one bike, we purchase 3 identical motors, and that helps to bring down the cost because we get higher volume of one single part. And when you have higher volumes, you get lower cost per part.
Right. So some unintended benefits of changing that.
Yeah, it was much smarter than what I wrote in the master thesis. There I used what's called a mid motor and converted that to a pedal generator. And that's quite expensive because there's a lot of heavy machinery, or not heavy machinery, but fine machinery to be able to pedal with very high torque and with low speed and bring all that gearing needed into a small housing. We have a gear ratio so that the wheel spins about 12 times faster than, the wheel spins 12 times slower than the motor.
Okay. And is it fixed, or do you change that?
No, that is mechanically fixed, just like an electric car. It's always so more or less all electric cars. There's a couple of exceptions, but electric cars, they have a fixed gear ratio from the rotor on the electric motor to the wheel, and we use the same principle. But we also have the same ratio for the pedal generator, and that is currently a little bit too low torque. So if you're very strong, you can pedal harder than the motor, which we use as a generator can handle. So then you kind of over turn it. But you learn very quickly to just change the speed, so you pedal faster, and then you are more in sync with the pedal generator. Maybe later we will increase the torque there, but for now we also want to bring it out in the market at a reasonable cost, and to do so we need to cut some corners, and that is all. Do compromises. I think that's a better word.
Yes, don't be Boeing, but do make some compromises.
We do have to make compromises all the time, but we have a fantastic front suspension. It's a multi-link front suspension, and that's quite unique. There are 5 ball joints on each side to the wheel carriers in the front, and we also have a very special wheels, which is kind of like a car wheel where you have room for brakes, etc., inside the wheel. And in our bike, that was quite essential because we have the pedals between the front wheels. And front wheels, you need to turn. And when you turn them, you don't want the wheel to enter the space where you pedal. That would be not good. So we had limited space for all the mechanics. So to put them inside the wheel, that was a good trick. And to do that, we could not use a normal wired spoke wheel. We actually went into cooperation, and that happened before we started Podbike. In 2013, I was on an exhibition in Germany, and I met a guy there who was making parts for Velomobiles. He actually made many of the parts that was in my Velomobile, the aluminium thing. And we come to discuss wheels. And for normal spoked wheels on a two-wheeler, there's not much sideways stress. But when you have a three-wheeler or four-wheeler that's not tilting, you will have a lot of sideways stress. And if your wheel is not built to handle that, the spokes starts to break.
Right, because those spokes wheel, it's really just for one direction of four. You're supposed to be down on it, and it's very.
They have a kind of V shape. The spokes from each side of the hub, but when you have, let's say, a chain gear, derailleur gear, the cassette takes quite a lot of the space. So the spokes on the cassette side, they are almost vertical. And the forces, sideways forces, need to equalize on both sides. So you don't have much strength sideways. And when you then start to have a three-wheel vehicle going fast in turns, you have maybe 1G on the wheels. And if you have our bike is 100 kilo empty, plus maybe a cyclist like me, which is, some kilo, 80 maybe. And then you have maybe a child in the child seat, and you end up, the total mass fully loaded is 230 kilo in our bike. And if you have 1G, you will have 230 kilo sideways force on these wheels, and most on the outside wheels. So it's very stressful on the wheels. So our discussion at this exhibition was that I did the engineering and the calculations, and he did the visual strategic decisions on how it should look aesthetically. And he, most important for me, he took the tooling cost. And then we made a plastic wheel with 60% glass fiber in the nylon matrix. So it's a thermoplastic composite, but it's very strong, and it does not corrode, because in Norway they put a lot of salt on the roads in the winter. So when you have an aluminium rim and you have brass nipples and you have steel spokes, you had a lot of challenges with corrosion, especially when it's highly stressed. You get so-called stress corrosion. So it's a recipe, or it's a good recipe for bad things. I think that's better to say. So plastic wheel is what we have, and it's only one nut in the center, so you can almost think of it like the Formula One racing wheel setup. Only one bolt.
Wow, there's so much that goes into these, right? And the average user of a e-assisted bike, an e-bike, right? All we see is, oh, it's a vehicle, right? It pedals, you get on it, it works, and there's so much that goes into making sure that it actually works when you get onto it and it goes where you need it to go.
Yeah, and to be allowed to sell it in Europe, you have to put on what's called a CE mark. That means that you follow all the European directives. And with regard to product safety, we had to find a standard. And there did not exist a European standard for wheeled e-bikes, but there had been made German standard, a DIN norm, Deutsche Industrienorm, for up to four-wheel cargo bikes. So we decided to use that standard. So I think we ruined 6 or 7 chassis to find out how to survive the German super tough fatigue test, where they actually put the bike fully loaded, 230 kilo. You put a lot of steel balls inside leather bags, and you strap it to the pedals and the steering handle and the seat and the cargo area. So the total mass is 230 kilo, and it should be divided so it's representative for normal use. And then you put it on a kind of shaking system. It's 2 drums, one for the front wheels and one for rear wheels, where they put on steel slabs that lift up the wheel, 50 millimeter, 30 millimeter, up to 70 millimeter. And then you spin these drums and you simulate, I think it's 20 years of normal use.
Wow. How long? A week. 20 years in a week. That is a lot of beating up.
And it's brutal and it's extremely noisy. And we ruined our 3 chassis in the laboratory in Germany, and that's cost a lot of money. So then we decided to build our own test jig so we can do the homework better. And then we ruined 3 more chassis there. And then we found out how to improve it. And one of the most critical things we learned was that if it breaks, it doesn't necessarily prevent it from further breaking by reinforcement. Some places we actually had to make it weaker. That's quite counterintuitive.
Very interesting.
Yeah, and there's a good parallel to this. If you have a huge storm and you have a small forest or a row of trees, and there are big trees, very big trunks, and you have slim trees with thin trunks, which will fall in the wind if the wind is so strong that they make trees fall?
It's probably the big ones. There's more.
Yes. Why? Because the small ones, they just bend in the wind. They do not bring that much force into the ground, so they are torn down. The big ones, they either break because they have so big green thing on top that catch wind, or they have too little under the ground to keep them there. So they turn over with the root and everything. So what we did was that we reduced the strength in some areas so the load was more evenly distributed. And when you do a fatigue test like we did, it's actually not the maximum strength you test on. What you test is what we call the fatigue strength. And since our chassis is made of aluminium, and aluminium does not have that high fatigue strength as steel, we had to be very scientific and counterintuitive on how we designed the chassis. That cost time and money, but it's a very good chassis now. It was quite good already because we only had one fracture area that we of course fixed on the big prototype series where we had 2 years of testing. Reinforced it on those, and we did not have any more issues. But that fix was not good enough for this German hell machine thing. It was a terrible machine. It's a torture machine for small bikes. It's not good to look at for engineers. But we now have a chassis that is approved, and the entire bike is more or less finished. We have, of course, a few things that we would like to improve upon, and we also have feedback from the customers. In the future, we will make it so it will park on its tail. Then you use the rear wheel carriers and have actuators that pushes them away from the chassis. So you raise up the rear end, and then you can lift it in the front, and it stands on the 2 rear wheels, and there's a rubber foot on top of the rear end. So it stands like on a tripod. But of course it's tall. It's 2.3 meters, 2.36 meter long. It gets slightly lower when it's raised because of it's a triangle then. But then you can park it on about 1 square meter. That is about 10 square feet.
Right, that's pretty small space then. It makes it a lot easier to store.
Yes, you can put 15 of those when you stack them tightly on a first in, last out principle. Let's say for rental, you can stack 15 on one single car parking lot. So you save a lot of space, and space costs money, especially in cities. So that's one good thing. Another good thing is that it uses about 1/10 of the energy of a normal electric car, 1/40 of an internal combustion engine car, and you use only 5% of the material that you use to build an electric car.
Amazing. Well, this has been really great. I love that we've been able to dive into the technical hurdles of trying to develop something like this. Before we wrap up, I wanted to make sure that we touch a little bit. I know you're the technical guy, but in terms of kind of marketing and sales, you talked a little bit about CE requirements. So that's Europe. Are you expanding into the US, Australia? Like where's your market and where are you growing to next?
We are now going into the Netherlands, France, Belgium. Netherlands, I'm a little bit unsure because there are some special regulations in the Netherlands that we need to know more about. We are going into Switzerland. We have just arranged with a distributor there. We have distributors in Germany. We are delivering direct to Norway, Sweden, Denmark, Iceland. We have delivered one bike to the US to help mitigate the issue that in current regulations for many states, a bike has to use 3 or 2 wheels.
Okay.
And taking off a wheel on 𝗚liche𝗯𝗲, I don't think that's a clever idea. So what the purpose of this single bike there is try to convince US bureaucrats and politicians that it is acceptable to have 4-wheel on a bike, even though it becomes more safe. It doesn't need to be a death trap. No, it's not a death trap.
Right.
But a 3-wheeler versus a 4-wheeler, where you have the same length and width, go out and test them. You will find out that 4-wheel is better.
Hopefully you're able to convince people and we'll be able to see your vehicle over here.
In New York City, they are now currently allowing 4-wheeled e-bikes for professional use because it seems like it's only professionals who know to use the 4th wheel. I don't know.
Well,
that was a joke. That was a joke. Yeah. The thing is that they are testing quite big 4-wheelers. They can transport maybe up to 1,000 pounds. I don't know. You can transport a lot with some bikes, 4-wheel bikes today. Our bike is for personal transport, and it's a commuter vehicle, a range, I would say, up to maximum 20 miles. However, in the States, you can go faster than in Europe. You can go 20 or 28, depending on classification. And you also have more assist power. In Europe, we have 250 watt, and I think you can use 750. This is the nominal or continuous output. Peak power can be higher, but you don't need that much more. You only need extra power when going uphill. And in Europe now, we have to go slow, down to about 10 kilometers per hour or 6 miles going uphill because of the power limit. So that's a huge challenge. We're working on trying to, we also in the standard committees of ISO and the European standard on the bike section. And we really trying to change from power limit to acceleration limit because that's much more focused on safety.
Yeah, that's a really good point. Yeah, the acceleration, it's not how fast, right? You're not going to do 100 miles an hour in this. So really acceleration is the dangerous point.
Yes, because you can, if you have very strong motors, you can have very dangerous acceleration. But if you just use the power to climb the hill and not to have insane acceleration, ludicrous mode, then things get not more dangerous if you have more power available.
Right. Got it. Well, this has been a pleasure talking with you, and we're wrapping up here. For everyone that is interested in your products, reach out, connect with you. I know you have your website. Is there any other platforms, or what's the best way for someone to connect and reach out to you guys?
We have on our homepage, podbike.com, the possibility of pre-ordering. And we also have a presence on Facebook and I think also on Instagram. And you can mail us hello@podbike.com.
Perfect. And for everyone who probably will wonder, how close are you? I know you're taking pre-orders. How close are you to being able to deliver, like final delivery for all of that?
Yeah, We have, for the last 18 months, been hand assembling the bikes in Norway. However, as of this summer, we have moved production to Czechia, and that is a more central location. So logistics gets much simpler, getting the parts to the assembly partner in Czechia and shipping finished bikes from that factory will also be easier. And they have the capability of producing many bikes per month. So if you order a bike now, you should get it in 2025.
Fantastic. Awesome. Well, thank you so much. I really appreciate you being on the show. This has been wonderful.
Thank you very much.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.